Hi guys, so what we're going to look at today are the rest of the properties on your chart. So we're going to look at odd even, cofunction, and sum and difference. We're going to do a little bit more with sum and difference tomorrow and Wednesday, but we're just going to start off just looking at kind of what those sum and difference properties are. So make sure you have that properties page near you while you are watching this video. So we're going to start with odd and even. Now we talked about this briefly back when we did our parent functions for tangent and cotangent and things like that. But just a quick refresher, an even function is when f of negative x is equal to f of x. An odd function is when f of negative x is equal to a negative f of x. Okay, so an example of an even function would be something like x squared. X squared is even because if I take negative x and square it, I still get what the original function was, which is x squared. All right. That also works if I plug in a value. Like let's say I plug in negative 2. Negative 2 squared gives me 4. But if I plug in positive 2, that also gives me 4. So again, f of negative x is equivalent to f of x. Okay. Odd functions, though, that negative doesn't just go away. That negative comes out to the front. So if I have, for example, an odd function like x cubed, if I plug in negative x there, negative x to the third power gives me a negative x cubed. It's still very similar to my original function, but it's the negative version of it. Same thing if I plug in a negative 2. Okay, negative 2 cubed is a negative 8, whereas f of 2 is 8. That means that f of negative 2 is equivalent to a negative f of 2. That's why that function is odd. Now what this means for us helps us actually with some of our trig functions, with the argument in particular. So there were two trig functions that are even, and these are listed on your properties page. They are cosine and secant. Because f of negative x is equivalent to f of x, if I see something like cosine of negative 30, I can just say that that is equivalent to the cosine of 30. So basically, any of those even functions, I can just drop the negative within the argument. That also works for secant. Okay, so any negative in the argument for cosine and secant, we can just drop it. Now the other four trig functions are odd. Okay, so that's sine, cosecant, tangent, and cotangent. For these, the negative can't go away, but I can move the negative to the outside. So for example, sine of negative pi over 2 would be equivalent to negative sine of pi over 2. So that negative can move to the outside. So that's the difference between their odds and evens. We use those properties to deal with a negative inside the argument. If it's an even, we can take the negative and just get rid of it. If it's odd, we take the negative and move it to the outside. All right, the next properties we're going to look at are our cofunction properties. When you're thinking of cofunctions, I would think of complements. Okay, complementary angles back in geometry. Learned about those, they added up to 90 degrees. Cofunctions are equivalent when their angles add up to 90 degrees. So each function has a cofunction. Sine's cofunction is cosine, cosecant's is secant, and tangent's is cotangent. Now what it means by cofunction is, again, they are equivalent when their angles are complementary. So for example, the sine of 30 degrees is going to equal the cosine of an angle that will make those add up to 90. And we know that that's going to be 60. Now if you look on your formula chart, cofunction properties, it would be listed as sine x is equal to cosine pi over 2 minus x. Just remember pi over 2 in radians is 90 degrees. Okay, so pi over 2 is 90 degrees. And that's basically what we did here. And that should have been an x, not a pi. Sorry about that. Okay, so we did the same process here. I said the sine of 30 was equal to the cosine of 90 minus 30, which gave me 60. So same idea here on this next one, but now we're looking at radians, okay? So cotangent is going to equal tangent when those angles add up to pi over 2. So I do pi over 2 minus 3 pi over 8. In order to subtract those, I need to get a common denominator. So that common denominator is going to be 8. So this becomes 4 pi over 8. And I subtract those, and I get tangent of pi over 8. Secant, again, its cofunction would be cosecant, so that will equal cosecant of 48, because that's 90 minus 42. All right, the last ones we're going to look at are sum and difference, and we are going to do a little bit more with these properties later on this week. But to start, we're going to look at just how to simplify these and how to look at those properties. So the first one we're going to look at is this long expression. Okay, this is something I can't evaluate because I don't know how to find the cosine of pi over 8 or the cosine of 3 pi over 8. But if you look at your properties, you'll see that the cosine of a plus b under sum and difference looks very similar to what we have here. It's cosine A, cosine B, minus sine A, sine B. Okay, so it's the same setup on your chart. So go ahead and find that if you haven't already, and you'll see what I'm talking about. The only difference here is that my A is pi over 8, and my B is 3 pi over 8. So I can simplify this to the cosine of pi over 8 plus 3 pi over 8. Then again, I can simplify this a little bit further. I can go ahead and actually add those together. That gives me the cosine of 4 pi over 8, which we know simplifies to the cosine of pi over 2. And then cosine of pi over 2, I can even evaluate. That's an exact value. Pi over 2 is up here. The x-coordinate up there is 0, so the cosine of pi over 2 is 0. So that whole thing simplifies to 0. Like the last thing is with sum and difference, just going the other direction, seeing when I have addition or subtraction in the argument and how I can expand that. What is really important to understand is that this is not the same thing as the cosine of pi plus the cosine of x. Okay, I cannot do that. This is not multiplication. I can't just distribute and say, okay, look, now it's the same thing. Okay, we cannot do that. Okay. That is very bad. Can't do cosine pi plus cosine x. Okay, there is a property that you have to use. We have to use that whole expanded property in order to find out what this actually is. I can't just distribute. That property wouldn't be there if I could just distribute. So cosine pi plus x works out to be the cosine of pi. So this is, again, following cosine a plus b. We're following that same property, except my a is pi and my b is x. So this is cosine pi times cosine x minus sine pi sine x. Then I can even evaluate this further by finding those exact values. Pi is this angle over here. The x-coordinate is -1. So I can replace cosine pi with -1. The sine of pi, the y-coordinate there is 0. And 0 times anything is 0. So all I'm left with is a negative cosine x. All right, we're going to do some more with sum and difference properties throughout the week. But for now, again, we're just looking at how to rewrite these and how to simplify them using your properties.